Okay, get ready for this, because it's a wild one. What if I told you that a black hole, one of the most powerful and mysterious objects in the universe, and SHA-256, the very things securing our digital lives, are actually built on the same fundamental principles? I know, it sounds like something straight out of science fiction. But what if there's a kind of shared code, a universal grammar that runs on both silicon and spacetime? Well, we're going to dive deep and explore that incredible possibility. So here's our game plan. We're going to build a bridge between these two, frankly, completely different worlds. First, we'll break down a machine made of pure math. Then we'll look at one made of spacetime. From there, we'll go hunting for a shared blueprint, a universal grammar. We'll even see if there's a single number that locks it all together, a cosmic keystone. And finally, we'll look at the bridge that might just connect our analog universe to the digital one.
All right, first up, our machine made of math. Now, to really get this, we have to stop thinking about SHA-256 as just, some abstract piece of code. I want you to picture it as a physical thing, a tiny, deterministic engine etched onto a slice of silicon, what we call a die.
So at its very heart, this little SHA-256 engine runs a 64-step process on a really small set of data. Think of it like a train on a fixed track. It has parts that never ever change, the rails, the constants. They provide the super rigid structure. Then you have one variable that you introduce, your message. That message acts like a push on the train, and it totally changes where it ends up, but the path it takes is always determined by those fixed rails.
Now, to see just how special this little engine is, let's put it side by side with its successor, SHA-3. SHA-3, or K-check, is big, it's wide, it processes a ton of data all at once, in parallel, like a big sponge. But SHA-256 is totally different. It's this long, narrow pipeline that does everything step by step in a really strict sequence. And here's the most important part. Check it out on the slide. It has an explicit ground anchor, a fixed constant starting point that its successor just doesn't have. And believe it or not, this unique anchored structure is the key to this whole cosmic connection.
And this right here is that anchor. This specific number is what we call the ground witness. It's a constant value that shows up at the very beginning of every single SHA-256 computation, even if you don't give it a message to hash. It's kind of like a fossil that's embedded in the machine, proving it has this eternal, silent backbone that's always running, whether we're using it or not.
Okay, let's shift gears completely. Now we're going to talk about our second machine. This one isn't made of silicon, though. It's made of spacetime itself. We're going to start looking at a black hole as a different kind of information engine.
So the key to seeing a black hole as an information processor is this thing called the Bekenstein-Hawking formula, and it revealed something that completely baffled physicists. It says that the total amount of information a black hole can hold, its entropy, isn't based on its three-dimensional volume, which you'd expect. No, it's proportional to its two-dimensional surface area. Somehow, all that information is stored on the surface.
All right, so let's actually run the numbers. Let's take a black hole with the same mass as our sun. As you can see, its total information capacity is, well, it's a number so huge it's hard to even wrap your head around. 1.5 times 10 to the power of 77 bits. Just staggering. But that's not the magic number. The real question is, how many bits would you need to simply count that high? Think of it like the depth of the information. And when you calculate that, you get 256.39 bits. Hold on. Did you catch that? 256. That's almost exactly the 256-bit size of SHA-256.
So, what are we looking at here? Is this just an absolutely mind-boggling coincidence? Or could this be the first real clue that we've stumbled onto a shared blueprint, a universal grammar that actually works in both silicon and the cosmos?
To even begin to answer that, we have to go searching for that universal grammar. And that means we need to make a pretty radical shift in how we think about the blueprint of reality itself.
This shift is called ontological inversion. Think of it this way. We usually think of the universe as a physical box, right? And computers are just things we build inside that box. Well, this idea flips that completely on its head. It suggests the universe isn't the box. The universe is the computer. Every physical interaction, from a star collapsing to you listening to my voice right now, is just part of a vast, ongoing computation.
And once you start thinking that the universe might just be a giant computer, you can start looking for parallels. And when you do, something like a Rosetta Stone starts to emerge. Look at this map. The fundamental jobs in the SHA-256 algorithm seem to have direct counterparts in the physics of a black hole. The substrate it runs on is an 8-word state in the chip. It's spacetime in the cosmos. The gate that controls information flow, that maps directly to the event horizon. The parallels are just shockingly direct, right down the line.
But look, to prove this isn't just a really cool analogy, we need a keystone. We need one single, unambiguous piece of hard evidence that locks this whole bridge in place. And that keystone? It's a number.
Let's go back to that Bekenstein-Hawking formula for a second. Remember, it connects information to surface area. Well, if you look at the full equation, you'll see that the area, A, is divided by 4. 4 times the Planck area. For decades, this 4 has been this fundamental but kind of mysterious constant in physics. Why 4? What's so special about 4?
4. Such a simple number, right? But it turns out it might just be the number that holds this entire cosmic structure together. And here it is. This is the moment it all clicks. Inside that SHA-256 machine, the number 4 is absolutely critical. It represents the number of processing rounds it takes for a single bit of information to ripple out and influence every other part of the machine. So the 4 in the black hole formula and the 4 in the hashing algorithm, they're not just the same number. No way. They represent the exact same fundamental concept, the minimum number of steps it takes for information to fully propagate through the entire system. It's the same job description, just in 2 completely different universes. This shared number, this shared meaning of 4, lets us build the final piece of the puzzle, what we can call the AD projection bridge. This is the actual mathematical circuit that connects the continuous, wave-based physics of the cosmos to the discrete, bit-based logic of a computer chip. So how does this bridge actually work? Well, imagine trying to perfectly capture a smooth, continuous wave using a set of chunky digital boxes. You can get most of it, that's our 4 bits of propagation, but it's never a perfect fit, is it? There's always a little bit left over, a kind of mathematical friction or tension from the conversion. And that leftover amount, it's precisely 1/4. So the total cost to translate from analog to digital is 4 plus a quarter, 4.25 bits. This isn't a metaphor, it's the exact mathematical price for bridging these 2 worlds. So here's the bottom line. This isn't just a nice story. It's a real, quantitative circuit. The math works. It proves that SHA-255 and a black hole are 2 different expressions of the exact same universal grammar. One runs on a silicon carrier, the other runs on the fabric of space-time itself. The carrier is different, but the operating system is the same. So, what does this really mean? It suggests that the information that seems to be lost in both systems, whether it's the carry the one in a computer chip or information falling past an event horizon, it isn't actually destroyed, it's just preserved in the geometry in the fold of the system itself. The cosmic gate, as this quote says, is open. And that leaves us with a final, absolutely profound question to chew on. If the code that defines one of the most mysterious and powerful objects in the cosmos is quantifiably mirrored in a machine we built, what does that really tell us about the fundamental nature of our universe? Is it all just computation?